number 1, this is the sine of theta, cosine of theta. We know that we're going to have to find that missing side in order for us to find the sine of theta because we need opposite. How are we going to find that missing side? Pythagorean theorem. Very good. And how do we use the Pythagorean theorem on number 1? 4 squared plus b squared equals 5 squared. Very good. And that's 16 plus b squared equals 5 or equals 25. When we subtract 16, we get b squared equals 9, and then we take the square root. So what is b equal to? 3. So this is 3. Do y'all see that? Are you sure? Okay, let me get a little closer. Okay, so the sine of theta, what is sine? So, toa. So sine is opposite over hypotenuse. So from theta, 3 is our opposite. And then what's our hypotenuse? 5. Okay, on cosine, what is our adjacent side? Over. And tangent is? Good. So then over here, this is just going to be 5 over 3, right? 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 I wouldn't do anything to try to trick you. Right. What's wrong here? Yes, ma'am. Hold on. What? You're right. Sine goes with cosecant, okay? Okay. If you're using pen, listen. That's not my problem. I need you to listen. I put this on here for a reason. You need to know that sine does not go with secant. That secant is not the reciprocal of sine. Cosecant is the reciprocal of sine. No, you just assumed. Cosecant is the reciprocal of sine. So this is actually secant is actually the reciprocal of cosine. All right, so this is actually 5 over 4 here, and cosecant is the reciprocal of sine, so this is going to be 5 over 3. The reason I want you guys to make sure that you know that is because in this unit coming up, you're really going to need to know that kind of just naturally. Yes, ma'am. Yes, ma'am. And if you, hey, Ella, maybe you want to move up closer. If you want to. Okay? So then what would the cotangent be? 4 over 3, right? Or 4/3. All right. Any questions here? Yes, ma'am. Yeah, go ahead. So, all right, let's look at number 3, okay? Do you guys remember how to go from degrees to radians? We multiply times pi over 180, right? Which we can't simplify 197 and 180, can we? So, or in radians, this is just 197 pi over 180. Okay, who can tell me what quadrant this is going to be in? Yes, sir. Yeah. Well, I mean, doing a sketch would help you. Is that better, Trent? Doing, yeah, an extra sheet of paper. Yes, ma'am. Yes. 5, 6, and 7 disappeared. I'm sorry. Sorry. Probably not the first error you're going to see on this paper. My apologies. Okay, so can you think about what quadrant this is in? 197 degrees. Yes, ma'am. The third. How do you know? You drew a sketch, okay? So we can draw a sketch, And we know that this is 180, but we're just a little bit past that, right? Which means we're going to end up in the third quadrant. And what is our reference angle? Remember, our reference angle is the acute angle made with the x-axis. So it's going to be just this little angle right here. All right, so how many degrees is that? 17 degrees. Good. Are there any questions? All right, on number 4, or I'm sorry, we'll go to 5. On number 5, sorry, I guess that is a little confusing. Let's go to 9. 9 sounds perfect. We want to multiply this times what? 180 over pi. Very good. So we can simplify this, right? We could do it together, or you can do it on your calculator. You got a decimal. If you got a decimal, remember you want to switch it to a fraction. You can do that using the yellow calculator by pressing math, enter, enter. What'd you get, Ella? 675 over what? Oh, I think you can get a decimal. Yes, I'm sorry. We're going from radians to degrees, so you will get a decimal here. So what did you get as your degree? 337.5? So when we're going from radians to degrees, we can have decimals with our degree, okay? But we always want to write our radians as a fraction. Are there any questions here? All right, let's do number, I want to go ahead and do number 10 just because I want you to see one like this. On number 10, what are we multiplying by? We're multiplying by pi over what? 180, very good. So I want y'all to go ahead and put that in your calculator and tell me what you get in as radians. What'd you get? 13 pi over 4. Did everybody get 13 pi over 4? If you did not get 13 pi over 4, please let me know. We're good? Everybody got? Yes, ma'am. Yes, yes, please. Okay, so we do need to sketch both of these. We'll go ahead and finish number 10. So if we're going 585, right? So let's sketch this. That means we're going to go around one time, right? So we already went 360 degrees, which leaves us with what? 225 degrees left to go. So that's 90, 180, and then 45 more to get to 225, right? So what quadrant do we end in? The third quadrant. And what is our reference angle? 45, very good. Remember, our reference angle is this angle right here. It's the acute angle formed with our x-axis, and that's going to be 45 degrees. Okay, and let's sketch number 9. So number 9 is 337.5, so that's 90, 180, 270, right? And then 337.5, somewhere around there. Okay, now our acute angle, which is our reference angle here, is this angle. How do we know how many degrees this angle is? How can we determine the measure of this angle? See how much is left over, right? So we would do 360 minus 337.5, right? Oh, and we ended up in the fourth quadrant. And that would give us, what, 22.5 degrees? Okay. All right, are there any questions?
What quadrant is it if it lands on line?
If it lands on an axis, you could just write x-axis, y-axis.
And what would the reference be? 0?
Well, it'd either be 0 or 90. Are there any questions? If it's on the y-axis, it'd be 90. If it's on the x-axis, it's 0. Okay. Okay, so it wants you guys to go ahead and sketch your unit circle, and I will do that as you guys do that on your paper. Try not to just write what I'm writing. Try to remember and try to do it on your own. Remember, we only need the the points, the coordinates, as well as the degrees. Okay, and let's also remember that the cosine of theta is equal to x, sine of theta is equal to y, tangent of theta is just the sine over the cosine, which is y over x. The secant of theta is the reciprocal of the cosine, which is just 1 over x. Oh, I'm sorry. Is that better? Okay, the cosecant is the reciprocal of sine, which is just 1 over y, and the cotangent is of theta is the reciprocal of tangent, which would just be the cosine over sine, or x over y. All right, so on number 12, it tells us the tan of 7 pi over 6. So some of us remember where 7 pi over 6 is, and some of us don't. For those of us who don't, we can just easily convert this to degrees by multiplying 7 pi over 6 times what? 180 divided by pi, and you can put that in your calculator, or you can reduce it yourself. If we reduced it ourselves, we divide by 6, we'll get 1 here and 30 here. Our pi's also cancel out, so this is the same as the tangent of 210 degrees, right? So we go at 210 degrees, tangent, remember, is y over x, or sine over cosine. So that would just be equal to negative 1/2 divided by negative square root of 3 over 2. Okay, and remember, when we divide by a fraction, it's the same as multiplying by the reciprocal. So we're just going to multiply by this bottom fraction, the reciprocal of the bottom fraction. We're just going to switch these guys. So this is equal to our numerator, which is negative 1/2, times, instead of square root of 3 over 2, it's going to be 2 over the square root of 3. Do you guys see that? All right, so then we can go ahead and let these negatives and these 2's cancel, and we're just left with 1 over the square root of 3. But what's wrong with this? Radical in the denominator. So we're just going to multiply the numerator and denominator by the square root of 3, and that gives us the square root of 3 over 3. And this is our answer. Are there any questions? All right. Yeah, we can get a 15 next. So 15 says negative 5 pi over 6, right? So to convert this to degrees, we would just multiply by 180 over pi, correct? Our pi's cancel. 6 becomes 1. This becomes 30. So then we just get what? Negative 150? So we want to find the cotangent of negative 150. All right, so to go to negative 150, remember we're going to rotate the other way, right? So we started here. We rotated 90 degrees, right? And then we need to rotate how many more? 60 more degrees, which would take us to 210. Let's draw a sketch. So on our sketch, we're rotating negative 150 degrees, right? So this is negative 90, and then how many more degrees do we need to go? We need to go 60 more, right? So that'll take us right here, which we can see is 210 degrees, okay? Now we're finding the cotangent of this, right? Do we already know what the tangent is, though? What is the tangent? I'm sorry? Root 3 over 3. We just found it here. The tangent of 210 is root 3 over 3. So the cotangent would be negative, no, it would be the reciprocal. 3 over the square root of 3, and then we just rationalize our denominator again. So we know that to take the reciprocal of that, which is 3 over the square root of 3. And then again, we multiply by the radical, the denominator. We get 3 square roots of 3 over 3. The 3's cancel, and so our answer is just the square root of 3. Any questions here? Since we're in the this quadrant, the third quadrant, they're both negative, so it would be positive, right? Any questions here? Okay, let's go to 17. All right, on 17, again, we want to go to go to degrees, so we'd multiply by 180 divided by pi, and what does that give us for degrees? Did everybody get 930? So we want to find that, this is 930 degrees, we want to find the cosine of 930 degrees. So we need to draw a sketch to figure out where that's going to leave us. All right, now we're going to go around once, that's how many? 360, right? And if we go around twice, how many is that? 720, right? So let's see how many we have left to go. What's that, 210 left to go? I'm sorry? Is that what you guys got? Okay, so then we go another 180 and we go to 210 here. And we're finding the cosine, right? What is the cosine of 210? We go to 210, and the cosine is the first one, right? So it's negative square root of 3 over 2. That was not a bad one, was it? Any questions? Please let me know if you guys have questions. All right, let's go to 19. All right, on 19, it asks us, it says negative 585. Remember, negative, we're going the opposite way. So we'll go around 360 degrees, correct? So that leaves us with 225 degrees. So then we go 90, right? 180, and then we'd go 45 more, correct, to get to 225? So we end up here. Okay, what degree is that? On our if we see here, it's right there in the middle. So what would that be here? 135? So we're looking for the cosecant. So the cosecant is 1 over what? 1 over y. Right, so it would be 1 over square root of 2 over 2, okay? So this is just 1 times the reciprocal, which is 2 over the square root of 2, which of course is just 2 over the square root of 2. But what's wrong? Radical in the denominator, so multiply by the square root of 2 with the square root of 2, and this is 2 square root of 2 over 2, which is just square root of 2. Good. Any questions here? All right, on number 21, pi halves is how many degrees? Who can tell me? Can you just tell me by thinking? Remember what? It's 90, right? Because remember, pi is 180 and pi halves is 90. But in case you forgot, you can still multiply by 180 over pi. Pi's cancel, and then you'll just have negative 90. So we're rotating negative 90, which would be right here, correct? Because if we rotated 90 degrees, positive 90 would be here, negative 90 is here. What are the coordinates here? And we're looking for the cotangent, right? So is that right on 21? So what's the tangent of negative 90 degrees? Well, what I was going to do is I was going to show you the tangent and take the reciprocal, but you're welcome to just go from here too. I'm sorry. We could do cotangent or tangent of negative 90 is y over x, which would be right. So then the cotangent is just the reciprocal, which is 0, correct? Are there any questions? You're right, I didn't have to do the tangent, I was just kind of showing. All right, good so far? All right, let's go over to our graphs. Okay, so remember that in order for the amplitude is just the absolute value of the number in front of sign, which is a, and here it's just 1, okay? And the period is equal to 2 pi divided by b. And in this case, what is our b? The number in front of theta, which is 3. So our period is 2 pi over 3. Do you remember that in order for us to determine how many intervals we're going to have between 0 and 2 pi, we want to multiply our period, we want to divide our period by 4, right? So that's 2 pi over 3 divided by 4, okay? So we want to multiply by the reciprocal of 4, which is just going to be 1 over 4. So that gives us 2 pi over 12, and that's going to give us pi over 6. I'm sorry, pi over 6 is our intervals. That's how much we're counting by, right? And to determine how many different intervals, we just multiply 4 times b, right? And that's 4 times 3, which is 12. So we're going to have 12 different intervals, each increasing by pi over 6. I've divided our period by 4. Okay, so now we need 12 separate intervals. 1, 2, 3. All right, I just counted 12. So the first one is pi over what? 6. The second one is 2 pi over 6. 3 pi over 6. 4 pi over 6. 5 pi over 6. 6 pi over 6. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. All right, any questions here? I'm sorry? Yeah, I didn't simplify these just to show you how I got them, but yes, you are welcome and encouraged to simplify them.
Oh, I thought that was 2 pi.
Oh, sorry, 12 pi over 6, yeah. So this would be 1, and this is negative 1, correct? And if it says negative sign, well, we always start with what? Regardless, in the middle first, and that's only for sine. For cosine, we start at our altitude, our amplitude, right? So we're going to start here at 0. And then do we go up or down? Down, since it's negative, since our amplitude is negative. So our graph is going to look like this. All right, any questions? And remember that B is your number of cycles. So go through and make sure you have 3 cycles from 0 to 2 pi. So that's 1 cycle, check, 2 cycles, check, and then 3 cycles. Do y'all see that? Each cycle being 2 pi over 3 long, which we know. And our amplitude is 1. Are there any questions here? Okay, we're good here? All right, let's go to number, do you want to do 26 together or do you want to do it by yourself?
25.
You want to do 25? We can do 25. Okay?
I thought we were doing
We are. I feel like the tangent ones are just easier. But we can definitely do this. Okay, so for tangent, remember, what's our amplitude here on number 25? 4, good. And what's our period? Remember, it's different for tangent. The period is different. Can y'all remember what it is? Instead of it being 2 pi over b, it's just pi over b. Very good. So in this case, it's period is equal to pi over what? 1/2. Good. So we could multiply these by just saying pi times the reciprocal. So our period is just 2 pi. Yeah, you only have to do 1 cycle. Because you what? Do it again. You don't have to do it again. Just 1 cycle, yeah. And I think it tells you in the direction, it says that you want to do it from 0 to 2 pi for sine and cosine, but you only have to do 1 cycle for the tangent, okay? Does that help? Make it more simple? Okay. Now, do you guys remember how to determine our asymptotes? Right. It's pretty much, it's just our cycle. It's half of our, it's half of our period, right? So what would that be? What's half of our period? Just pi. So here's pi. Okay, and it's positive, right? So we're just going to go, oh, this is 4, negative 4. Okay? Any questions on number 25? All right, you said you wanted to see one on the back? Like, do you want to see one where we're given the graph and we have to find the equation? Okay, it's my suggestion that we do number 32. Is that okay? I understand that it's not an odd number, but look at 32, okay? Is this sine or cosine? This is cosine because we start at, we know it's cosine because we start at 5, right? I'm sorry, because we're not starting at our origin. and A is equal to 5. And what is the period? Remember our period? If we start here, we go down and back around, our period is pi. Do you see that? It takes us, yeah. The period is 1 full cycle. So if we're starting up top and we go down and back up top, that's 1 full cycle. So from 0 to pi is 1 full cycle. So the period is pi. All right, now if the period is equal to 2 pi over b, and we know our period is pi, we can just now solve this equation. Cross multiply, and we get 2 pi is equal to b pi, or pi b, however you want to look at it, divide by pi. Yeah, bye y'all. Period is 2 pi over b. So our period is pi. Pi b, pi b. Yeah, I think that, I'm sorry? Oh, we don't have to solve. Why do you think this is tangent? There are no asymptotes. I'm sorry? I'm sorry. Yeah, none of these are tangent. Tangent have the asymptotes. Remember, tangent looks like this one. Right. So do you see how these cosine and sine? Okay. So when we divide both sides by pi, we just get b is equal to 2, which means that there are 2 cycles from 0 to 2 pi, right? 1, 2. So to write our equation, it's just y is equal to a, which we found is 5, times the cosine of b, which is 2, theta. The rest of it, yeah. And the rest of it, all that stuff, that's the last thing we covered in this class too, so that should be the most fresh on your memory. Please remember, your homework is going to be to finish the rest of this, and please also remember that you do have a test tomorrow. Remember that I have tutoring every day after school that you are always welcome to come to. Hold on one second.